Hey guys, Mr. Creed here, back again with another video. Yesterday we talked about independent events, which is where the outcome of one event does not impact the outcome of another event. Today we're going to talk about dependent events. Okay, dependent events are when the outcome of one event impacts the outcome of another. Okay, so we're going to go through a couple of examples. We're going to identify what would be an independent event and what would be a dependent event. Okay, all right, so. Um, a dependent event, again, the outcome is affected from one event to the other. Okay, so let's say drawing a deck of cards, for example. If I take one card out and look at it, I don't put it back in the deck, then the outcome of choosing another card would be completely affected because I have one less card in that deck of cards now. Okay, let's go through these 5 examples and let's discuss what these are, what kind of events this would be, independent or dependent. Okay, number one, flipping 2 coins results in one landing on heads and one landing on tails. Regardless of what coin you use, you have 2 sides of that coin, heads or tails. Now you might come across a coin every once in a while that might have a heads and a heads or a tails and a tails. That's what's called an unfair coin. Okay, if you ever see a video on Khan Academy that talks about unfair coins or unfair events, that would be an example of that. So we got 2 coins we're flipping. What's the probability of landing on the heads or landing on the tails? No matter what coin you're flipping, you're you're going to have 2 outcomes, either heads or tails. No more, no less. So flipping one coin in this case will never affect the uh, outcome of flipping another coin. Okay, so this would be an example of an independent event. Okay, the outcome of one coin does not affect the outcome of flipping another coin. Okay, all right. Number 2, the captain of a football team is selected, and then the co-captain is selected. Let's think about this. Let's say you got 25 guys on a team. Okay, you got 25 players. One of those you're going to choose as a captain. Okay, does not matter who it is. Could be the quarterback, could be running back, could be a lineman, defensive back, whatever. Okay, it does not really matter who you choose, but you're going to choose one player. So you can only choose one player out of 25. Okay, to be selected for the captain of the football team. Okay, and in this case, you've chosen that person. Well, the captain cannot be co-captain. So therefore, you have one less player to choose from. Okay, so you now have 24 people to choose from to choose for your co-captain. This would be an example of a dependent event. Okay, you have 25 guys to start out with to choose from to be your captain. Okay, you've chosen that person. Great. Uh, Joe Jones is now the captain of your football team. Now, out of the 25 players, one of those your captain. Now you got 24 left to choose from to be your co-captain. Okay, Joe Jones is the captain. Let's say that we'll say Xander Cage. That's from a movie. You guys are familiar with that character, but he is now the co-captain of the team now. Okay, so this would be an example of a dependent event. Okay, because you take one person out of the group of players to choose your captain, then you have 24 players left to choose for your co-captain. Okay, this would be this would be an example of a dependent event. Now, number 3, you draw a joker from a deck of cards, and then you draw an ace. Something I want you guys to notice here. A joker is not really a part of a deck, but in this case it is. Okay, so usually you got one joker. So you got 53 cards to choose from. So the probability of choosing a joker from a deck of cards would be 1 out of 53. Okay, so 53 cards, one is joker, and you have then you have a whole bunch of sets there. You got 4 sets there to choose for ace from. Okay, so this here it can become somewhat confusing, but I want you to know something here. It does not say anything about replacing the card or putting the card back into the deck to choose another card. So essentially, I'm going to assume that we're going to draw a joker out of this deck of cards and then not replace it. So that means my next probability would be 1 out of 52 to choose an ace. Sorry, 4 out of 52 to choose an ace because there's 4 aces in a deck of cards. Okay, but notice how I went from 53 cards down to 52 cards. Very similar to the problem of the football, the captain deal here. You went from 25 players to 24 players. Now you went from, in this case, 53 cards to 52 cards. These are examples of without replacement. Okay, without replacement. It does not. If it says anything about not replacing a part in your event, then it's going to be a dependent event. This is dependent. Okay, because you have now affected the probability of drawing an ace from this deck of cards after you have drew a joker. All right. Now number 4, this can be a little different here, and I want you to pay attention. You draw a queen from a deck of cards. Okay, so 4 out of 52 cards are queens. You take this deck of cards, you take this queen, you draw it out, you put it back, you replace it, and then draw a 10. You're replacing the card, you're putting it back into the deck. So now you pretty much went from 4 out of 52. I'm sorry, you went from 52 cards to 52 cards. I did say that correctly. Your number of cards did not change from one probability from one event to the other. Okay, so you draw a queen from a deck of cards, replace that card back into the deck, and then draw a 10. There are also 4 10s out of 52 cards. Okay, so your probability has not changed, or your number of cards has not changed. Therefore, this is an independent event. Okay, as long as the number of cards have not changed from one event to the other, the outcome has not been affected. Okay, and then number 5, I talked about this yesterday a little bit, and maybe some of you guys remember what this is. Okay, whether it be independent or dependent. A coin is flipped and a number cube is rolled. These two are completely different things here. Okay, a coin has 2 sides, a cube has 6 sides. Okay, neither one of these events here are going to affect the other. Therefore, this is going to be an independent event. Anything with coins, okay. If you have, this is my little hint or even a clue or secret for you. Okay, anything with a coin is going to be an independent event. 99.9% of the time, any kind of problem you have with a coin is going to deal with an independent event. Okay. All right. So let's talk about formulas. We talked about the formula for independent probability event yesterday. Okay, probability of A and B equals the probability of A times the probability of B. Okay, neither one is affected here. Now, dependent is going to be a little different. Probability of A and B. You're still going to have the probability of A, that's the first event, times the probability, that is going to be different, probability of B given A. Okay, the probability of B here is affected by the probability of A. Again, this is kind of like these two right here, 2 and 3. The probability of choosing a co-captain is affected by the probability of choosing a captain. Or the probability of choosing an ace is affected by the probability of choosing a joker. Okay? This is known as conditional probability. Conditional probability. And conditional probability is essentially is that it's pretty much the same thing as saying that the outcome of one event is affected by or has been affected by the outcome of another event that has occurred already. Probability of A has occurred already, and probability of B is affected by what has occurred in probability A. Okay, such as a deck of cards without replacement. Okay, so probability of A. So what this is going to look like, and then we're going to do 6 and 7 here. That way we can see an example of that. Okay, so we're going to use this here. Okay, so for example, for a deck of cards, probability of an ace, okay, times the probability of another ace. That would be 4 out of 52 to begin with, times 3 out of 51. I started with 4 aces, a spade, club, heart, or diamond. I chose an ace, could be any ace, could be out of that set. I'm not putting that card back into the deck, therefore I'm left with 3 aces out of 51 cards. Okay, let's look at number 6 here. Neil goes to the pet shop and selects a treat for his dog. He chooses one and then chooses another. What is the probability that Neil selects a bone and then a ball? Okay, so look all here. He has all these right here to choose from. 1, 2, 3, 4, 5, 6, 7 things that he can choose from. So the probability of choosing a bone is going to be 1, 2, 3 out of 7. Well, the bone he's going to buy regardless. So that is going to be one less thing that he's going to have to choose from. Okay, so we take out a bone. He got that. Okay, so now I'm left with 6 items that he can choose from. So the probability of choosing a ball would be 2 out of 6. Okay, so now with multiplying fractions, we can figure out what this is and just multiply across. Okay, so we got 6, 3 times 2 is 6, 7 times 6 is 42. This can be simplified. 6 and 42 do share a common factor of 6. So if I divide by 6, top and bottom, this becomes 1/7. So the probability of choosing, of Neil selecting a bone and then a ball would be 1 out of 7 chance. Okay? All right. Number 7, Mackenzie chooses one candle and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? So how many candles do we have? We have 5 candles. So the probability of choosing a polka dot candle the first time would be 1, 2 out of 5 chances. Okay, let's say that she picked a candle. She picked a polka dot candle. So now I have one less candle to choose from. So we're still trying to choose. So I got 4 candles left. We're still trying to choose a polka dot candle again in the next event. We got 1 candle here that is left as polka dot. So we're left with that. So now we can multiply across. 2 times 1 is 2. 5 times 4 is 20. This is also similar to 1/10. So you have a 10% chance of choosing a polka dot candle both times if this was a randomly selected, if you were to randomly select these candles. Okay. I hope this has helped, and I hope you guys have learned a little bit. Make sure you like this video, comment if you got any questions, hit that subscribe button if you hadn't already, and I will see you guys later. Thanks.